So that little code that we had an example of up on the board, I just made it up. This code has a very specific name, and it's called a hex code. Now what a hex code allows us to do is take a number that is bigger than what we can normally work with, but still get it down to a format that we can work with. The easiest way to explain it is to have you think a little bit about the number system as you know it right now. Everything that we calculate, money, numbers in algebra, are more or less in a, well actually, they are completely in what's known as base 10. So what I mean by base 10 is when you start counting at 0, and you go 1, 2, 3, 4, 5, 6, 7, 8, 9, in your mind you're thinking, okay, the next number is 10, but where 10 is actually saying, hey, we completed one cycle going through these numbers, so we begin again. So you go 11, 12, 13, 14, 15, 16, 17, 18, 19. That's our second cycle completed. So we're back over to 20. Makes perfect sense. The problem is the way we want to get these numbers down is a little bit different because hexadecimal is not in a base 10. Take a look at what it's got. It's got some letters in it. If we were to take 256 and divide it by 16, which is what base a hexadecimal is. Hex is in base 16. That means we get 16 different options. 16 times 16 is 256. So what we're saying here is we need to have other options to keep this code nice and small. This code here, professional programmers use, web designers use, anyone who's in any kind of design, including fashion and textiles, understands the basics behind a hex code. So with hex being base 16, we expand out what is our normal range before we ever get back to 10. So we need 16 different spots. Right now I have 10 of them covered. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, because you count the 0. So what could I possibly use to give me the rest of my numbers, 11 through 15, before we get back to a complete set at 16? What about letters? Let's use letters. So I'm at 10, or I'm at 9 as the number, I should say, even though it's the 10th spot. So then I have an A, which would be 10, B, which would be 11. Make sure I'm not going to run out of room here. 12 is C, 13 is D, 14 is E, and 15 is F. We go through that whole cycle before we ever get back to here. So in reality, number 16, when we're used to counting, is represented by 10. So why do this? It's done this way so that we can have a short code that the computer can still take a larger range of numbers and properly process quickly and efficiently. See, back when video games and computers were first made, they weren't up to the same speed that your cell phone has. In fact, they were tremendously slower. I can tell you some stories about that when you're not watching a video. So they needed to get this to be as small as possible to make your computer seem as quick as possible back then. They never changed it because it's quick and efficient. So in the next video, I'm going to show you how to actually calculate these numbers.